Good afternoon, everyone, and welcome to our webinar, this lunchtime webinar on using not just free LiDAR data, but generally accessing sources of data that we could then create a model using XP-SWM 2017. My name's Peter Coombs, and I'm pleased to be welcoming my colleague Ludmila Fadeva, who'll be joining me with this webinar today. The way that we'll run this is that I'll run a brief introduction. We'll look at the required elements for creating a model of an existing situation. We'll look at some sources of data that are available and thank our colleagues over in France and Germany for helping out with this, actually. Some interesting sources on the continent that we could access. And then I'll hand over to the main part of the day, really, is to hand over to Ludmila. And Ludmila will be providing you with a live demonstration on how we can utilize all this information and create flood risk assessments and drainage assessments at the beginning of projects, or help the local authorities with their flood risk mapping and the environment agencies around the region. So we'll take a look at those elements required for modeling purposes, and it's the visualization, it's not just for the sake of, but to be able to actually identify properties, the location of flooding aspects, where the flooding is coming from, where it's traveling to. It's really important to provide this visually for those approving authorities and for the members of the public as well that have been suffering from issues of flooding, for example. So let's take a look at where we can access some background mapping and some sort of CAD data. First of all, we'd think of places like in the UK Ordnance Survey. So we can click on the link and you'll be able to see that we can access a range of information. There are local maps, so you can zoom in and extract data either in a raster format or as an Esri shape in GIS information. And accessing the information from here and CSV, for example, all of these different formats. If you're looking at the river network, we can bring in the rivers. Ludmila will show you this a little bit later on live with the software. But that data can be downloaded, and you can see that some of this is actually quite big in size. So, I mean, first tip really is to try to zoom in on the local issue, but then have information, sufficient information surrounding your local issue to be able to generate a representative model. What we will do today, by the way, folks, before I carry on, is we will have to answer your questions at the end because at the minute we are showing a laptop and I'm going to be running another webinar immediately following this one, so I can't access and answer any questions live. We'll just have to answer those at the end for you. So do feel free to post your questions in the little pop-up box that you can see. You can message us and we'll respond to you accordingly. So yeah, so we can bring in information from OS. We can bring in information from OpenStreetMap as well. So if we take a look at that, the nice aspect of this is really just representing the land usages. It's not bringing in so much intelligent information, better just to show what that information comprises of. Is it a highway? Is it a building? Is it a green space? So again, that kind of helps when we're sharing this kind of information and aiding people to orientate sort of flooding situations, etc. Moving on, we've got from Germany, this is an interesting website, Geo Fabric with a K.de. And if we take a look at this, you've got an extensive library. We just have to move here to look at the downloads on the top right hand of the screen. And then you can look literally across the world. But if we take a look inside Europe, and then we have Great Britain, which would coming down to here. So we just look at Great Britain, for example. As you hover over the different countries within the spreadsheet, you'll see that the country of England's been highlighted. So we click on the link there, and then we have the different counties. So we're in Berkshire, here in Newbury. So if we click on Berkshire, now we can see the extent of Berkshire and the information that we can download. And this information with a range of different common formats, all of which we can bring into XP-Site 3D. And on the top line here, it's probably very small on your screens, but it's basically saying that it's updated as of the 14th of March this year. So that was yesterday. So they're constantly updating the information that's available for you to download. We mentioned in the title the LiDAR data, so very grateful for the Environment Agency providing this for us nowadays. So we can click on the Environment Agency link, and here we have terrain data. So what we can do is we can access digital terrain models, we can access digital surface models at a range of different degrees of accuracy. So if we zoom into our area here, we can see that there is composite data, but you also have just DTMs, digital surface DSMs and DTMs, and a range of scales. So if we just expand, for example, you can see that you can get 2x2 resolution, a 1x1 resolution, all the way down to 25 centimeter by 25 centimeter spatial resolution. So the key thing here is if you go for the 25 by 25 over a large area, you will find there will be a massive amount of information. And in terms of utilizing that and analyzing it, you just need to be aware. So we'll show you what we've downloaded anyway in a second, and how quickly or slowly, as the case may be, that we can import that information into your models. And what Ludmila's just done here now, we've just put in our postcode of RG14 1BD. You run on the search, we can click on the RG14 1DB there, and then it zooms in and centers that postcode into the middle of the screen. And then from the drop downs below, you can access the data. So it's a good way of zooming in and focusing on your local tiles of data. And then enhancing things a little bit further, you might want to add in aerial photographs. The Google Earth, it's okay if you are subscribing with Google Earth Pro, but you do need to be paying the subscription on that. So the free Google Earth, you won't be able to download the photographs and utilize them for commercial purposes. And then QGIS, there are map extensions that we can utilize as well, or to just help orientate people when we're analyzing existing issues. Further north, just looking north of the border into Scotland, this is the work in progress. So you can see that they're working on phase 1 at the minute. So if we access that, similar to the Environment Agency LiDAR data that we have in England, you now have the first phase coming together in Scotland, covering the whole of Scotland. So that's going to be utilizing the Open Government License data that's now freely available to everybody. And the nice thing is here you have forums, and they will update us and tell us how they're progressing. So you can see that the next update is expected to be available by the end of next month. Yeah, again, you have DSMs and DTMs. This similar to what we showed you before, 2 meter resolutions down to 0.25 meter resolutions, etc. But it's covering the whole of the country. So yeah, need to be a little bit careful, because that will take some power to run. And so what we're going to do, I'll hand over to Ludmila very shortly, and then she'll show you how we can bring in terrain data. We can then add in the river networks. We can add in the land usages, incorporating buildings, incorporating roads, what the different land use is in terms of the crops, etc. So we can build up a detailed picture of a model, and then we can apply rainfall onto grids or generate hydrographs to generate flows of water within river systems, drainage networks, whatever you may have to hand, and show how we can work on probably the flood risk assessments and drainage assessments at the beginning of a development project. So without further ado, I'll hand over to Ludmila and show the live demonstration, Ludi.
Thank you, Peter. What I have done prior is I have downloaded a number of files. And if I just open my folder, just to show you what I have. So I have multiple background images downloaded from different sources, which we described today. I will have building shape files and another shape file of building, but which was cut to my extents. I will have river center lines, not maybe exactly center lines, but river lines. As well, I will have an XYZ file, which was created from LiDAR data, or England LiDAR data. And yes, basically what I will do, I will package it all together in XPSWIM live for you and show you what you can do with all this data. So I will be working in metrics. And the first thing I would do, I will load my background image. Oh, sorry, not background image, my LiDAR data. So I will select my XYZ file. I will click open. It will take a couple of seconds to load because obviously there are many points, and as you have seen, LiDAR does work on tiles, right? So if I just go back and so in here, right, so I can't get less than a tile size, right? So this is what I'm getting. I'm getting a tile for Newbury. So once I am loading it in here, XPSwim will tell you how many seconds left till it loads in. So the data is in. Now when I hover over, you can see in here X, Y, and Z coordinate. I may take some sections and have a look. So this is a road. So I can't control this data much. So what is provided, right? But I can straight away recognize this is the river bridge I'm crossing every day, and this is the road I used to go to the office. And it's quite good because all we did, we downloaded some files from internet, and we are like, oh yes, this is our marketplace in here, this is the road, this is the bridge, this is the Robin Hood roundabout. What we can see straight away from here is that we have a high level ground and we have a lower level ground towards the river, and river runs in here. What I will do next, I will load some GIS files, but I will load them only as a reference, as background. So I will start with a file called Water, which was downloaded from the open sources. And you can see it covers all West Berkshire, or perhaps even all Berkshire, right? And this is our location. So if I want, I can open GIS and trim it, but I didn't want to trim it. So I'm just using it as a reference to kind of confirm, if the data is viable. And I can see that actually, yes, it does follow the river as it's on LiDAR. So the other GIS data I will load will be called buildings. And again, I will load it only as a just background reference. And it is downloaded from the German website where they have the shape files, the polygons for every building. And as Peter mentioned, they are updating it all the time. So if there is some data missing for you now, we obviously can't help it because this is open source, but perhaps after some time they will improve it and we will have more data available. This is Reading in here, so we can see it's very dense, right? And if we want to work in Reading, we can see what's happening in there. But our point of interest is Newbury, so we will go inside. At the moment, all this is just a reference, right? So what I would like to do next, I would like to create a model where I would like to put some water on my model and actually analyze some flooding, which may occur just from the rain, from surface water. For that, I will create a layer under topography, and I will create something called elevation shapes layer, and I will call it houses. So what I will do, I will import again my building file, but I will import a cutted version of it. So I select import from GIS, I browse and I select building cut shapefile. I click open, I click import. So number of vertices 5,647 objects came in. And so yeah, we get zoomed out to the extent of our model because we have all this information in there. But if you don't need it, you can either not load files or you can cut them in GIS prior to loading, so you don't get kind of kicked out every time of your area of extent. Okay, so now if I untick the elevation shape layer, you can see it sits exactly on top of my GIS because this is exactly the same file. And what I'm going to do, I'm going to give all these buildings an elevation because my DTM is basically my digital terrain model. It doesn't know how high are my buildings. So what I will do, I will double click on one object and I will change all elevation. I will adjust existing elevations and I will put a number of, 150, so 15 centimeters. I will say all objects, I will click OK. Right, so remember we did it only for this particular object, but now if I double click on any other object, it keeps the same value because we did it for all objects under this layer. So I can check it, and you can see all of them are now 15 centimeters higher than my length. What I will do next, I will create grid extent within my LiDAR data, so my area of interest, and I will give my grids a size, so maybe 10 meters, 5 meters, 2 meters, depending on what analysis you would like to do. I will create another layer which is called rainfall flow area. This is where I will be applying my water, and I will put it at the top. I will need to assign a rainfall, so what I will do, I will quickly generate an FSR rainfall. So I will click create storm, 20, there was it 0.4. England, 100, 15 minutes, generate. So it's auto, if you have FEH data, so you can use it, FSR, so yes, now we have a rainfall. We can generate multiple rainfalls if we wish, just by ticking all the relevant boxes. So what I will do now, I will assign this rainfall to here. Right, so we have options how we can use this orange field. We can just apply rainfall on the area which is covered by the orange field. If we have any 1D elements with hydrographs inside, we can read a hydrograph from a 1D element, or we can just create a hydrograph in here, insert rows and put time against flow, but we will be using rainfall for now. So I have my grid, I have my buildings, I have my area where the water will be coming. I need a land use. Again, I would need to create a land use in the global data. I will say mixed, add record. I can edit it, so I can edit the numbers, I can edit the munnings, I can make munning variable, add rainfall obstruction, add infiltration, soil type. So there are options. I will keep it simple. Once we have done all of this, and obviously we didn't download the data in front of you, so downloading data takes maybe about 10 minutes. Yes, so far we spent maybe another 10 minutes of just putting things together. The last thing we would need to do is activate the controls, right? So we want to run the 2D model. We want to select what outputs we would like to see. So there are different maps available. So we will stick with that. That's good. We would need to activate our hydraulic runtime. So we will run it for 24 hours, or maybe we want to run it for a few days, or maybe we want to run it only for a few hours, maybe 6 hours. We can say yes to that. And I think we are good to go. I can click solve in here, and if everything is okay, we should be running. So what XPSWIM does, it typically gives you errors and warnings. Errors is something when the model won't run at all. Warnings is something which you may pay attention to. So whoever has the software and have been on a training course, they know how it works. But it's quite easy because you get line by line what is wrong and where the attention needs to be paid. So you can see the model is running, and in here it runs with 10 by 10 cell size, which is not a very precise size, but for some very quick assessment of what will happen, it will work. So we have a model which has been run already. We will keep this one in background, right? So just to show you that basically it takes minutes to get the results. But in here, apart from having all the data which was before, I loaded as well a background image. Right, so I had multiple images as I showed you in the beginning. So I chose the one I preferred, or perhaps the one which doesn't imply any license, so we don't need to pay money. Yeah, it's straight away georeferenced. If you take it out of QGIS or if you take it out of OpenStreetMaps, it will be georeferenced. You just need to make sure that the referencing system you're working is a British grid, and your image will come together with your LiDAR perfectly. So what can we do in here? This model, by the way, was run on a bit smaller cell size. I think it was 5. And if I click maximum water depth, we can see that all this became wet, right? And we can see how the streets kind of became channels and the water was channeling. And we can see where the ponding areas are, right? So we can bring the legend, which color represents what. So theoretically, if we would be interested to put development in this area, maybe we didn't even have a project assigned to us yet. We just been asked to price how much it will cost. But we want to know how much problems we may have through planning, because perhaps we not only need to do flood risk assessments, but we need as well to provide certain proofs that these properties won't be flooded from outside, etc., etc. Just to make sure, you know, that this water, we just basically use the topography and its natural ways that it's sloping from one way to another, and we will know that the water will go like this. We just put some obstructions like buildings, right? So to make sure that it's more realistic, we added LiDAR, which kind of shows us the carriageway, maybe not to a millimeter, but it's quite good call. And we can see that actually in here there is a huge ponding, and potentially if this land goes for development and we will be contracted to prove that it won't flood, we may have an issue. So in a way, with all this free of charge source data, you can load it in a relevant software package. And as Peter mentioned, you can load it, like some of it in our road design package, or even you can use some of it in micro drainage. You can very quickly get the results and see what's happening without buying any data, because all of it is available in there. For sure, maybe it's not to a centimeter or millimeter. There is obviously some tolerance issues, but you can have a general feeling what is happening on your site. And now I believe our model did run. And if I click maximum water depth, right? So in here we had a slightly bigger extent of the orange in comparison to previous model, right? So if I just untick the surface, so we can see that in here we have a slightly different picture. First of all, the cell size was bigger. Second of all, the orange doesn't match 100%, so we made it a bit wider. So there is, and in a way you can see that in here, because this is end of our data, it kind of considers it as a wall, right? So perhaps if we are interested in this corner here, we just need to have a couple of tiles more. We need to have a bit more data around and just see what happens, because maybe all of this floods away somewhere else.
And the other thing is, if you did need to model the existing drainage networks, or even with the micro drainage, proposed drainage network, that kind of information can be brought in as well. Up towards the top on the left-hand side, we have the nodes and the links. So at the minute, we're just working with digital terrain models and placing buildings upon them.
You can import micro drainage data, and you can import flood modeler data if you have any river models.
Yeah, exactly. Most people who work with
land XMLs, etc. I just want to point out at the precision, right? So this particular model was run with 5-meter grid cell size. And if I zoom in here, right, so we can actually see how the water goes quite accurately around the buildings. And we can obviously see the values as well of what is the depth of water. So if we zoom even further in here, we can see that some of them are like really small and some are a bit bigger, but we can see how it's like kind of accurately flows around. If we reduce the cell size to 2 meters, we will have even better results, right? And the model which we did run live in front of you, you can straight away see how the squares are a bit more bulky, I would say. And in here, if I just improve a bit how it looks, and I add the result values as well. So we are looking at exactly, I think, same location. So we have this circle in here, and we have this circle in here, right? And if we compare them, so in here, the building is kind of more flooded rather than in here, right? This is because as the cell size is bigger and the average value for a cell is just, let's say, less accurate.
And that water depth shown there, that's the water depth above the sort of threshold level that we set at sort of 300 millimeters. So you've got another 160 millimeters on top of the 300 millimeters. So it's breached the threshold.
It was, I think, 150 I put.
Oh, sorry. 150 plus the 160 above the 150. So it's 310 mil kind of total depth in a way. So it's breached the threshold, and then you have 160 mil of water within the property itself. And of course, all these results, we can actually extract those results. So we can right click and extract those results from the tree view. And those exported results, you can then maybe check the extent of the polygons of the flooding and find out what the postcodes of the buildings are. You can link up with your postcode
so we can see the velocities as well. So we can see not only the arrows, but as well we can click on again display result values, and you will have a value for every single cell. What is the velocity value? If you wish to run a hazard map, you can straight away run a hazard map on it as well. But what it helps us without basically any much information about the site, without any much investment in data and site investigations, to have some basic results and actually, see how much work may potentially be involved in sorting these problems, etc. Or maybe sometimes you just want to see where is the dry spot, if there is a landowner, and he wants to sell a certain spot and he wants to make it quickly and without any issues. So perhaps all he needs to know is identify what is the dry spot in there. And here it is, and this is the best to go out for development.
Yeah, funny enough, there's a lot of our clients, like consultants, working on behalf of clients who are looking at acquiring land, and they may not just be housing developers, but they could be landowners as well. Thinking farmlands, etc. And what's the issue? Are there any areas of the land that could not be utilised and the asset affected by extreme rainfall conditions? I mean, we've used just one event here, but you can use a range of different events, you can add in for climate change, we can add in for longer duration storms, more extreme rainfall events, etc. And then do a range of comparisons and scenarios.
Yeah, so we can restrict our depth of water. Say we don't want to see 1-2 centimeters. We think it's not feasible. We don't want to know anything about it. We want to start from 5. So we can click OK. And see straight away the map changes dramatically because all these little pieces, they go away, right? But we still have some problems in here. Obviously, remember where Peter mentioned that we had some flooding in the building, right, where this circle was. But in general, we can potentially see that, okay, basically it's not that dramatic as we thought, but in here it still stays, right? And the green, you can see the range of green is 1.7 meters, right? So there is, and this blue, it's 600. So it's kind of, potentially a location for a pond or for a swale.
And just really interesting to see the main road, the A339, the major road going through the middle of Newbury there, acting as a barrier. I mean, that's not off the extent. That's not like a glass wall.
Yeah.
With our grid, that is literally acting as a boundary. And we find this with the railway network as well, with the railway embankments.
Yes.
So there you go. It's kind of ponding in the lower region to the west, and then you have the elevated highway that's gone in there. Now we're trapping the water. This
and
really common.
This is a Victoria Park, and we can see that potentially all this water could be just stored in the park. Yeah, for an event.
Well, that's right. You could utilize the public open space, and that would be a great place to utilize the public open space for extreme condition. Yeah.
But we don't have any drainage system, so perhaps if we put a drainage system, all this water will drain.
Could be culverted out and away, or into the river.
Yeah, and we don't utilize any river information so far, but we can extend the model at later stages. So you can start with very simple analysis, and as you go, you can import your micro drainage, you can add your river, and you can move with the model from very early stage to...
Good point, because we can also, if anyone's using FRAs or programs like that, or as you say, Flood Modeler, we can import those models directly in, which include the catchment areas and the characteristics of your existing natural water courses. They can be built in. If you need to develop the bridge idea, we have a really good bridge tool as well, so we can replicate that bridge and the abutments of the bridge, which will act as a constriction. So for any kind of consents when you're building in and around ordinary water courses, that would be super useful. If the terrain data is really accurate, and this isn't necessarily as accurate as I would like, we could develop the river and build in the cross sections of the river. So Luda's just clicked on the right hand side.
No, it's not very accurate.
Yeah, you see. So what I would do is, maybe you have some survey information.
This is LiDAR, right? So
exactly.
It depends how much water was in the river.
So we could improve this. Yeah, we could improve this along the line of the river. We could have, wherever the cross section of the river changes, we can introduce nodes and links and develop that 1D river network model that we're interested in. We're just going to check a few questions as we're going through. So my eyes are not that good. I can't read the text.
We've been asked what is the name of the German website again, and geofabric.de with a K.
Yeah.
Yeah, but this video will be recorded.
Yeah, so you'll have the links. You'll be able to have the links and then access that information from the PDF. We'll do a PDF of that.
James is asking, is it possible to import land use data? Yes, if you have land use in GIS, you can import it. So once you create your land use names, you can in here just import from GIS, right? And whatever land use it is, it will import the polygons, and then you can give them characteristics. And when the water will be moving through that particular land use, it will be picking up the characteristics of this land use.
Yeah, that's a good point. We've done that in previous webinars. We brought in maybe highways, buildings, and the different crop types.
Yeah, why isn't the rainfall applied to the whole site? Just as an example, you can apply it to the whole site and see what happens.
Exactly.
You can apply it to a much bigger extent. It's up to you. You can, create a very small rainfall area at the top of the site, and then you can create a dummy 1D node and describe a much bigger catchment in there. We can create a dummy 1D node, and we can, generate a hydrograph out of this 1D node. We can say that maybe, this 1D node represents 100 hectares.
Yeah.
Right, and then inside we can give it whatever hydrology method, routing method we want to be using, which rainfall, etc., etc. And then once we run it, there will be a hydrograph generated, which we can then apply to our strip. And basically all this hydrograph will be coming to our extents without even needing to have a map for 100 hectares. Yeah. There are different ways how you can use it.
And it's just to give an example, really, just to show that what you can do is save computation time as well, because if you put in the whole 100 hectares to the north of the site, that would bring in a lot of data, a lot of terrain data in. So you can, knowing what the software can do, you can sort of link those hydrograph details to the grids.
Yeah, we have two good questions. Does this demonstration include pre-existing drainage systems? No, we have 0 in here, but you can import them. If you have micro drainage models, if you have any other models, you can very simply import them through databases, land XMLs, or micro drainage files if you have, and then they will be taken into account. So at this point, this is just, we are working with free data. We don't have anything else. Can you...
The other one I was going to say there, that's a really good point. And if you were working with maybe drainage systems that are existing, but they're flooding right now, and you have like a culvert under a highway or something like that, we could set that up very quickly and easily. But you can also use the software to identify what the size of the culvert needs to be. If it's maybe now receiving a higher runoff than it was originally designed for, you can utilize XP-Swim to resize the culvert for you.
Can you apply losses to the 2D environment, example, infiltration? Yes, we can. When we have our land use, so in land use we have a data part, right? So in here we can add infiltration, we can tick it on, and then we can select soil type in there. So if I go inside, I can, let's say 1, I can say add. And in there, I can select a soil type, either from predefined soils, or I can select my own, right? I can add porosity, suction, all other parameters. I can select my infiltration method, and then the infiltration will be counted in for your land use. And you can do this for every single land use. So if it's asphalt, you can put 0. If it's grass, you can put something else.
And of course, this is the beauty of using GIS data, because what we can do is we can have, within the land usages, we can identify all the roads, we can identify all the different grassy areas with the similar soil underneath, and then do that kind of universally. You don't have to do it on every single polygon. You can do it every single silty clay would have this characteristic, for example.
We have a question, what is the legal restriction for using the various data sources?
Do check when you go to the websites, because they're clearly stated. I mean, certainly with the Google Earth, etc., you have to have the Google Earth Pro. You can't just use the free one and utilize the imagery, etc. And again, just double check with the Environment Agency, etc. They'll be, when you're downloading, they'll come up with the terms and conditions for you, so you can check that.
Typically, if it comes under government open source license or just general open source license, it's available to use for commercial. Right, but obviously, as Peter says, double check with providers, and because in a way, if you use, let's say, an Open Maps background image, and if this is under open license, you are absolutely free to do it. Right?
Yeah. And also, this isn't to replace the good work that the engineers and the land surveyors are doing, because at the end of the day, this is all digitized information, so there will be errors within there as well. So you need to walk the site, and this is something that I've like from day one, sort of 30, 40 years ago, I would always like bring information together, create an image in our minds, but then you'd go down and literally walk the site and then check things out. In reality, that's what the engineers are for. It's just to try and help speed up the processes and give you an aid to get a clearer picture, just with desktop study work, really. But it doesn't replace what we do on the ground.
Another question, if only grids can be used or any other meshing techniques. At the moment, only grids, because this is a two-flow engine we are using. So two-flow classic runs on grids, so this is grids, but potentially in future there will be other techniques available.
The other question comes up is how do we improve the information? Well, we can either do land survey and bring in the additional land survey information, or a lot of people now are using drones, and you can utilize the drone information. So that may be something of interest. We've been engaging with a number of companies who do that kind of work as well. And the accuracy it can be down as good as plus or minus 1 centimeter.
Yeah, a good question from Evan. What sets this mapping apart from EA's freely available flood map for surface water? I would say EA mainly. They have fluvial.
It's fluvial. Yeah. So the EA work is fluvial. So it's rivers and coastal type flooding. And then what we're finding increasingly is that the flooding that we're exposed to increasingly isn't the fluvial from the rivers. It's pluvial. It's just extreme runoff. So it's another reason why we kind of purposely for the demonstration have not included the drainage networks, because when you get extreme rainfall runoff, all those networks are completely full up with water anyway, and they're flooding across the surface. So yeah, we're looking really at the extent of the pluvial flooding. So where the overland flood routes find their way into depressions and in between buildings, etc. This is the kind of work that we're doing increasingly at the minute.
Yeah, so for instance, the Thatcham town, which was flooded in 2007, 10 years ago, via fluvial source, which was an extreme runoff from the upper catchment. It's not even now on EA map of extents 10 years after, because they only map the river, they don't map the surface water itself.
Yeah, that's right. But the beauty of this, by the way, because we are using two-flow, which the Environment Agency kind of like, when we export those results, we can export them to the grid square size. They want 2 by 2 grid squares. So the grid square size and the format that they like to improve their surface water flood maps. And that goes for the local authorities as well. So it's kind of industry compliant formats that we can export in. Great. Well, thanks a lot for the questions, folks. And thanks for the demonstration, Ludi. That was really interesting. And as ever, thoroughly enjoyed. So hopefully that's shown that there are a range of free data sources now freely available. You will get the links when we carry out the recording. We may have to have a PDF that you can click on the link and then take a look for yourselves. Hopefully it also showed you how the latest technology will help you to provide that invaluable evidence, particularly to the approving authorities, the Environment Agency, the local authorities, etc., and local residents to help with your flood risk assessments, your drainage assessments, and those surface water management plans. We're in the next cycle of the floods directive requirements, so we're revisiting the preliminary flood risk assessments that were initially submitted in December 2011. So December 2017 is a review process. So all the local authorities and the Environment Agency have to resubmit to Europe, because we're still going to be within Europe by the end of the year, with an update on the preliminary flood risk assessments. And the XP SWM will help you to provide that industry standard technology to give the appropriate outputs and ensure that you're complying with the local needs.
I can see there are more questions coming, but guys, I will give you a call after. Or I will ask your account managers to give you a call and reply to the questions, because we are just running out of time.
Yeah, I got to do. Sorry, folks, I got to do a webinar at 1 o'clock for a company outside of England and that as well. So the upcoming events. So 21st of March, which is next Tuesday, there's a free half-day workshop being held at the National Motorcycle Museum in Birmingham. So if you haven't already registered, then you still have time. It's a free place, and we will spend the morning sharing an update on the latest legislative requirements and standards, etc., and showing you the whole range of softwares that we have available. So we'll give you an update on micro drainage.
BIM.
But yeah, BIM is a major that we're focusing on right now as well. So micro drainage and BIM, XP Site 3D, the road design package, which is so popular across the whole of Europe, Middle East, and Africa at the minute, and an XP Swim, which is the software that Luda's just shared with you earlier on in the live demonstration, where we're modeling existing situations.
If you're not near Birmingham, check our website, because we have upcoming workshop in Leeds in April.
We do. Leeds in April, and we are in Bristol in May. Newcastle is in June, but it's all on the website, and we look forward to meeting you. It'll either be myself or Ludi or Dan, Ruth, the team, Max, etc.
Yeah.
And Mike. Yeah, there'll be a range of us covering different aspects in different locations. And then we have micro drainage training coming up in April. That's courses A, B, and H. H being the checking and auditing one.
A good thing to mention, if you're in Leeds, we are running a Leeds training course
in
April.
Yeah, that's right. That
A
was
and B.
A and B at Allen Road is the location there, the football ground. And the next webinar is in 2 weeks' time. So we're running kind of parallel series right now. We run monthly micro drainage and monthly XP Swim webinars. And the next one will be what's new in micro drainage 2017. So the latest release will be coming out in due course.
Yes, we are expecting very, very soon.
And if you're working as a group, then please get ideally each person to register in the future, because then you can just put in that password and then access your CPD certificate automatically. If you're working as a group and there's just one person that's registered, you can email ukeducation@xpsolutions.com with a list of the other attendees. And then what we can do is we can issue a CPD certificate retrospectively, but that takes a little bit of time and effort. So ideally, register as an individual.
We will be happy if you provide any feedback as well. You can just email us with topics you would like us to cover.
Yeah, so just let us know if there's any particular hot topics that you'd like us to cover, and we'd be more than happy to introduce us in the webinar series. So thanks, Ludi. Really appreciate that. Thank you all for your participation and for joining us, and look forward to keeping in touch and seeing you again in a couple of weeks' time. Have a good day.
Bye-bye.